Okay, so in this lesson we're going to discuss the hot air balloon type problems, right? And then we're gonna look at problems involving two objects. So to start off, we have a hot air balloon here. Sorry, yeah, here we got a hot air balloon. It says a hot air balloon moves vertically downwards at a constant velocity and the likes. On hot air balloons, what you just need to perhaps take note is that the balloon itself, that hot air balloon itself, it is moving. Okay, that's what you need to take note of. It is moving. So at the same time it is moving, someone that is inside would maybe drop. Either they will maybe throw a ball upwards or an object up, or they will throw the object down. So what is only going to be affected, because you're working with a hot air balloon, what is only going to be affected is the initial velocity. The rest of the calculations, you do them exactly the same. What is only going to be affected is initial. So how do we get the initial velocity? You have to say it's going to be a vector sum. You're going to say the velocity of the balloon, the velocity of the balloon plus the velocity at which it was dropped or thrown. Okay, this is the initial velocity when you're working with hot air balloons. Okay, and you must make sure that you choose direction, because if you don't choose direction, you're gonna get wrong answers. Okay, so understand that before the object is dropped or it is thrown, the object will be moving at the same velocity as that of the balloon. Okay, so when it is still inside there, the velocity of the object is the same as that of the balloon. But once it is dropped or it is thrown, the initial velocity of the object can only be calculated by saying the velocity of the balloon plus the velocity of the velocity at which it was dropped or thrown with. But if it is dropped, you know the initial velocity there would be the velocity there would be 0. Something that is dropped means the velocity starts off as 0, but if it is thrown, it has a certain velocity. So yeah, just to clarify that again, when the object is still inside the balloon, they are moving at the same velocity. But once the object is thrown or it is dropped, this is how you calculate the initial velocity of the object. Now, and don't forget to choose direction. Okay, so we're gonna look at this and try to solve the questions there. So it says that a hot air balloon is moving at a constant velocity of 1,2 meters per second. Constant velocity, which means the net force on the balloon is 0. This is the net force on the balloon is 0, which means in terms of friction and the force of gravity on the balloon means force are balanced on the balloon. I'm not talking about the object inside, but technically it will be the same thing. So when it reaches a height of 22 meters from the ground, the balloon, a ball is dropped. If the ball is dropped, that means here the velocity should be 0 meters per second in terms of the of the object. Okay, because something that is dropped starts off with 0 meters per second. Okay, so assume that the dropping of the ball has no effect on the speed of the hot air balloon, meaning the speed remains as 1,2 for the hot air balloon. Explain the term projectile motion. So remember, projectile motion, it is what? Motion under the influence. Motion under the influence of gravitational force only. Okay, of gravitational force only. Motion under the influence of gravitational force only. And then 3.2 says, is the hot air balloon in free fall? The hot air balloon, is it in free fall? What do you think? You said no. Why did you say no? Oh. Mm. Oh, if here they had said only explain the term projectile, that is the one you would give there. But if they put motion, then it means they are asking you about free fall in another way. Okay? Great, great. So now, indeed, the hot air balloon is not in free fall. So for 3.2 there, for 3.2 we say no, because the F net on the balloon is equals to 0. Okay. Remember, if something is in free fall, the only force acting is Fg, which means F net can't be 0. F net is actually going to be equal to the Fg. Okay, so take note of that. Then 3.3 then says calculate the time it takes for the ball to hit the ground after it is dropped. That is 3.3. So we need to know now what is the time that the ball is going to take to hit the ground after it has been dropped. So usually what I do is that I encourage you to say work in segments. So we're gonna do something like this. We can make it something like this. Then we say A is from when the ball was not dropped, and then to B is when now the ball reaches the ground. Information we have from A to B there is that at A we know that the velocity of the ball is 0 meters per second, isn't it? It has to be 0. Why? Because it is dropped. And then the velocity of the balloon is gonna be 1,2, okay, meters per second, 1,2. And then we do know the acceleration, right? It's 9,8 meters per second squared. And then we do know the we're looking for the time, by the way. They said the time, right? Yeah, we're looking for the time. And we do know their height though, because the displacement is gonna be 22 meters, because from there to there is 22, because it's been dropped 22 meters above the ground. So it means it's gonna cover 22 meters and then touch the ground, right? So how do you solve that? You're gonna need to choose the equation. Now for you to choose the equation, you need to choose from the 4. Remember that our equations are here, so I'm simply gonna take them. So when you have to choose your formulas, you then say, okay, change in y, which formula has change in y? This has change in y, this also has change in y, this has change in y, this doesn't have change in y, so already this formula is gonna be out. Okay, then we say which formula has acceleration. So this has acceleration, this has acceleration, but this doesn't have acceleration, so this one is already out. Then our time, right? This one has time, this one doesn't have time, so it's already out. So that leaves us with only one formula there we can use. So what we'll do, would write that change in y is equal to vi change in t, and then we say plus half a change in t squared. Now our change in y is 22 meters, but you have to choose direction. Please choose direction. So we're gonna choose upwards as positive. Okay, choose upwards as positive. Since the object is going down, our displacement is gonna be negative 22, because the object is going down. The initial velocity now, remember, now you have to calculate the initial velocity by saying the velocity of the balloon plus that one. So I'll say velocity of the balloon plus velocity of the ball. Now the velocity of the balloon is 1,2 and it's going down. Since it's going down, you're gonna put that as negative 1,2. And then the velocity of the ball, of the object, is 0 because it was dropped. Okay, so it means our initial velocity is going to be negative 1,2 meters per second. Great. So now we're gonna put negative 1,2 meters per second, and then we do not know the time it took, because we need to know the time it took to reach the ground, and then plus half negative 9,8 because it's going down, then we say changing t squared. Then from there it's gonna become a quadratic formula. We need to solve for changing t. So you're probably gonna have negative 4,9 changing t squared minus 1,2 changing t, and then plus 22. So this is your a, your b, your c. You're gonna put that into the quadratic formula, meaning you'd say change in t is minus b, right? Make sure to put negative, plus or minus. So we're doing a little bit of maths there. Negative 1,2 squared minus 4a. Our a will be negative 4,9, while our c will be 22. Then you will divide that by 2 into that negative 4,9. So we get our answers as, so our answer would be changing t is equals to 2 seconds. That is a very nice answer there, and that is the correct answer. So it means it took 2 seconds for the object or the ball to reach the ground. Okay, so please, I want to reiterate that the initial velocity is the one that is affected when we're dealing with hot air balloons. You must just make sure that you calculate it in this way, making sure to also consider direction. So whatever direction you're gonna choose, you would be applying it on this formula there. Then you're able to get to initial velocity, which you can put there now to find your answer. Okay, now the next question says calculate the time it takes for the ball, when the ball lands on the ground, it is in contact with the ground for 0,3 seconds, and then it bounces vertically upwards with a speed of 15 meters per second. 3.41 says calculate how high the balloon is from the ground. The balloon, how high is the balloon from the ground when the ball reaches its maximum height after the first bounce? Yeah, it's a lot there. It's quite a lot. So we need a clear understanding of what is going on. So for us to quickly do that, good people, please allow me just to take everything we did so far here and just try to take it to the other side where we can work on it. Now, let's understand the question. Let's break it down. Here is the ball here, right? It is still maybe like, it is still 20 meters from the ground. Okay, it is still 20 meters from the ground. And then what happens is that it goes down and then reaches the ground. Once it reaches the ground, it bounces, meaning it goes back up, and then it reaches the maximum height here. It reaches a maximum height. Now it's coming from a height of what? It's coming from a height of 22. Remember here the height is 22 meters. Okay, then it's gonna reach another a maximum height there when it's going up. Now the information we know so far is that the initial velocity of the ball is 0 meters per second. Oh, sorry, the initial we calculated it to be negative 1,2, right? Meters per second. Sorry, I can't write meters per second, but I hope you can see it there. And then now, when it reaches the ground, we don't know at what velocity does it reach the ground. So from A to B, we don't know at what velocity it reaches the ground. But from B prime, remember I like to call this B prime because it's still at the ground, and then we have B prime to C. Okay, so we have B prime to C, and then we want to know now, we know at C that the velocity is gonna be 0 meters per second. That one is for sure. So when you read the question, it says that calculate how high the balloon is, right, from the ground. Okay, when the ball reaches its maximum height after the first bounce. So for you to solve this, it might seem like it's a lot, ne? It might seem like it's a lot, but think of it this way. You want to know, ne? you want to know how high is the balloon, right? Because remember, the balloon is going down. As this ball is going down and then it's bouncing, right, it might come down and then it bounces, but it does not mean that the balloon remains in the air. It is also continue to go down. So we want to know how high will be the balloon once this guy has reached his maximum height after the first bounce. So for us to know that, it's very simple. We need to know how long is the total time taken for this ball to reach its maximum height, meaning how long does it take the ball to reach the maximum height. If we can get how long it took the ball to reach the maximum height, then we're gonna add that time to the 0.3 seconds it was in contact with the ground. Remember, it was in contact with the ground for 0.3 seconds. We would add also that time. Then we're gonna also add this time that we got in 3.3. Remember, in 3.3 we said how long did it take to hit the ground? Remember, we said that it took 2 seconds for the ball to hit the ground. So we're gonna also take that time, which was the 2 seconds. If we take that 2 seconds plus the time it was in contact with the ground, and then plus the time it takes to reach its maximum height after the first bounce, if we can take all of that time, we can use it to calculate how far the balloon has gone down. Because all that time that the ball was doing its thing, the balloon was also going down. So if we can get how long it took the ball to do that, to reach the maximum height, how long did it take the ball to move from A to B prime and then to C, then that will give us the time, and then we can use that time to get the height of the balloon. So we are just needing this time. So let's just talk about some of the variables we have. We know the final velocity at maximum height is 0. We know that acceleration is 9.8 meters per second squared. What else do we know? We know the initial velocity. We know the velocity at B prime. Are you aware that we were given the initial velocity, or the velocity at B? We were given that it's 15 meters per second because they said that it bounces vertically upwards with a speed of 15 meters per second. So we already know that. So since we already know the speed, it makes things easy for us. So now we can choose a right formula there. So I'm just gonna take this and then take it that side. So today, guys, I'm not struggling with it. Yeah, here it is. Now we just have to check we can take this as final velocity and then as initial, because we are looking at B prime to C. Remember, I told you that when you're working with calculations, you work in segments, meaning A, B, B, C, C, D. Okay, and if you check the previous video, then it also goes deep into using that method. So we're just continuing with that method. So at B prime here, we know it's initial velocity. At C, it's gonna be final velocity. So we tick everything with initial velocity. Wow, everything has initial velocity. Let's tick everything with final velocity. This doesn't have final, so we're gonna cancel it. We're not gonna use this one. This has final velocity, and this also has final. So now we check the one with acceleration. This has acceleration, this doesn't have acceleration, so we cancel it, and then this has acceleration. Okay, and then now do we know the height here? We don't know the height, and this one is changing Y. So we're probably not gonna be using this one, or we can simply say we want the time again. So which one has time? This doesn't have time, so it's not gonna work. So it leaves us with only one formula to use. That is how you use it, this table, guys. So you're gonna have VF is equals to VI plus A change in T. Still upwards is positive. Final velocity is 0. The initial velocity is 15, and it's positive because it was going up. And then the acceleration is negative 9.8. Then I'm gonna calculate how long it took it to move from B prime to C, meaning to leave the ground to the maximum height. So we're gonna have negative 15 is equals to negative 9.8 change in T. You divide by negative 9.8 both sides. then you would get your time there. So your change in time would be equal to so it's 15 divided by 9,8, 15 divided by 9,8, so that would give us 1,53 seconds. So that is 1,53 seconds, which means the time there, guys, it is 1,53 seconds. So now we have the total time. Since we have the total time, now we can use it to answer the question. So how are we gonna do that? So I'm just gonna move this side a bit. So to then answer the question now, remember this is still 3.4, ne? Yeah, this is still 3.4. This is the whole of 3.4. So now I got the total time. So I'll say the total time elapsed. Total time is equals to the 2 seconds that the ball took from the balloon to the ground, right, plus the 0,3 seconds it was in contact with the ground. 0,3 seconds. Please, this is S, it's not 5, guys. This is very the letter S, I write it in a very ugly way, so I'm sorry for that. And then here 1,53 seconds, 1,53 seconds. Okay, so those three are the total time that the ball has traveled. So that gives us so we're gonna have what is 2 plus what 0,3, and then you add the 1,53, then you get 3,83 seconds. 3,83 seconds. That's the total time. Now we can use this time, right? We can use this time in the initial velocity of the balloon. Remember, the initial velocity of the balloon is how much? Is negative 1,2 meters per second, because the balloon was going down. So we can use, now we're talking about the balloon, not the ball, ne? So we're saying the balloon's initial velocity is 1,2. The time it took is how much? Is 3,83 seconds. We want to know how far has it went down. You understand? How far has it went down? That's what we want to know. And acceleration, we do know. Oh, guys, remember the balloon is not in free fall. So because it's not in free fall, we can't use acceleration as 9,8. Instead, your acceleration is gonna be 0 meters per second squared, because they said the balloon is moving at constant velocity, and whenever something is moving at constant velocity, its acceleration will be 0. Okay, so you can't use 9,8 because the balloon is not in free fall. Right, so now we're gonna choose a formula using this information that we have here. Trust me, guys, there must be a formula that we can use with that information. So I'm just gonna clean this real quick and fast, and then we're gonna start ticking now. The first thing we're gonna tick is initial velocity. It is there, it is there, it is there, it is there. Then let's tick change in time. It is there, it is not here, so this is out. It is there, it is there. Now let's tick change in y. There is no change in y, it's out. It is here, it is there. Now let's tick acceleration. Doesn't have acceleration, this one. So we'll choose this one. Okay, so that is the formula we're gonna use there. That is how you simply choose a formula. So now we can use that to solve the problem. So now we can say change in y is equals to vi change in t plus half a change in t squared. Change in y is what we are looking for, right? The initial velocity is negative 1,2. The time is how much? Is 3,83, and then the acceleration is 0, and then the time is 3,83 squared there. Okay, So what you find is that now the answer would be the 1 comma 2, you multiply that by 3,83, so the answer will be negative 4,596, negative 4,596 meters. Okay, so what does this negative 4,596 meters tell us? This means that the balloon has moved from where it was, it has went down. I carry the negative means downwards. It has went down how many meters? It has went down 4,596 meters. It has went down 4,96 meters, which could be maybe this small distance here, you see, which could be that small distance. So for us to find how high is it from the ground, how high the balloon is from the ground, we have to say the 22 meters minus the 4,596, then it will give us this small portion, which is how high is the balloon from the ground. So we say the height from the ground, will be the 22 meters minus the 4,596, and then if we use our calculator there, that height we should get it as, so we say 22 minus the 4,596, so that gives us 17,40 meters. Then you get your 6 marks there. What a very beautiful question. Any question there? So this is the second question here that I would like you to give a try. You can just take a few minutes, to write it, and then after that we can look at the solution. So a hot air balloon is rising at a constant speed of 4,9 meters per second. So take note that this speed here is for the hot air balloon, and since they said it's a constant speed, it means the hot air balloon is, the net force on the hot air balloon is 0. The hot air balloon is not in free fall. Okay, so at a height of 80 meters, right, above the ground, a ball is released. They're saying it is released. They didn't tell us whether it was thrown or whether it was dropped. That's very important. They're just saying it's released. But we do have the speed of the velocity of the balloon. Write down the acceleration of the ball before it was released. 3.1.1. The acceleration of the ball before it was released. Guys, please remember that I said before it is released, the ball is moving with the same velocity as the balloon. So it means since it will be a constant velocity, it means the acceleration would be 0 there. So for 3.1.1 you should have it as 0, or you can write it as 0 meters per second squared if you want. And then 3.1.2 says write down the acceleration of the ball after it was released. So after it was released, remember that it is now when it is thrown outside. So when it is now released, remember that it is now in free fall. The ball will be in free fall, but the balloon won't be in free fall. The ball will be in free fall. So acceleration in free fall is always, remember I was saying this a lot on our last lesson, that acceleration will be 9.8 meters per second squared downwards. So that is the answer there. And in 3.2.1, it says calculate the position of the ball 0.5 seconds, right? 0.5 seconds after it was released relative to the ground. Position of the ball 0.5 seconds after it was released relative to the ground. So this question is a bit ambiguous because we don't know whether this ball was thrown or it was dropped. So you know what, the best bet here is to assume that since they're saying it was released, is to assume that it was dropped and not thrown. Okay, so that means when we look at first of all, I'm gonna choose up to be positive. Then when I look at the initial velocity of the ball, I'm gonna say it is going to be equal to the velocity of the balloon plus the velocity of the ball itself. So for the balloon, it's going, they said it is rising, so I'm gonna write it as 4,9, and I'm gonna write it as positive because it's going up, where up is positive. Well, here I'm gonna say the velocity there is 0 for the ball. I'm gonna assume it was, remember we don't assume in physics, but by the way it released, it is just telling us that it was dropped. You understand? So initial velocity will be 4,9 meters per second. Then from there we can then get the position, right, relative to the ground. So 0,5 seconds. So we do have the time. So the motion we're looking at is from here, whereby velocity is 0, to somewhere in the middle here. I can just call it B, whereby there the time from A to B was 0,5 seconds. That's what we are looking at. So hence I'm saying here the time that I'm taking is 0,5 seconds. We know the acceleration is gonna be 9,8 meters per second squared, but we're gonna put it as negative, remember, because it up is positive. Then what else? We are looking for the position, so we're looking for the let's look for the displacement first, meaning to say how far did it travel from A to B. That is our change in y. So we're gonna find an equation that will assist us in terms of that. So we're gonna take this, we have it here. Right, now we have to tick. So initial velocity, this has initial, this has initial, this has initial, this has initial. Change in time, this has time, this has time, this has time, this doesn't have time, so it's out. Acceleration is there, it is there, it is not here, it's out. This one, change in y, there is a change in y, it doesn't have change in y, it's out. So our formula, it is there. We use change in y is equals to v initial change in t plus half a change in t squared. So now we can say initial is how much? This is the one, 4,9. Time is how much? 0,5. Acceleration is negative 9,8, and then we have 0,5 squared. So what do we get as our change in y? So we get our answer as positive 1,225 meters. Oh, so if it's positive, guys, it actually means that the height of the ball after it was released is how much. Therefore the height of the ball, let me just maybe write it here, the height is equal to, remember it's 80 meters. If it's positive, it means it was actually going up. I mean, yeah, maybe it was on its way up. So it's like 80 plus 1,225. So the answer would be 81,23 meters. That is the height. So let me explain to you guys, why do we get it like that? This is because what is the initial velocity of the ball? It's 4,9. It's positive, which means when the ball was released, it didn't immediately go down. It started by going up first. You see, it started by going up first, and then after that it's gonna go back down. You understand? Because it started going up first by a velocity of 4,9 meters per second, which is the one we calculated here. So the initial velocity tells you that the object was going up first. So it's gonna go up, then here the velocity is gonna be 0 at its maximum height. Then it's gonna go down. Another question could actually ask you to say how long did it take to reach the maximum height. Okay, so that 4,9, that's why the signs are very important. 4,9 means the object there, the ball was going up. So as it was going up, that means after 0,5 seconds it was somewhere around 81,2523, which means maybe it was somewhere around here, 81,23 meters. Perhaps that's where it was there. Okay, so that is why you get it like that. Okay, so that is its height. Then 3.2.2, we need the time taken by the ball to reach the ground. So if we're saying the time taken by the ball to reach the ground, now what are we referring to? So we're trying to say how long did it take to move from A to B and then to C, meaning to reach the ground there. Now you have two options. You can go the longer way or the shorter method. The longer way would be to look at A to B, calculate the time it took to reach maximum height, and then calculate the time it to take from maximum height to C, and then from there you add them. Or you can simply focus on position A and position C. What is the information on A? If I'm looking at A and C, it means all the information on A would be initial, all the information on C would be final, right? So it means at A there we know the initial velocity is 4,9 meters per second. We do know that the change in displacement from A to C, that distance is 80 there. So our change in Y is 80 meters. But I'm gonna put it as negative. Why? Because A to C we are going down, so we have to put negative 80. That is the displacement there. And then do we know the time? No, we do not know the time. Do we know the velocity at C? No, we don't know nothing. We don't know the velocity at C. We know the acceleration is negative 9,8 meters per second squared. So using that, we need to find the answer. So now we're gonna find the formula, guys. Just to save a bit of time, but no, let's go. Let's go take it again, guys. I need you to get used to you getting the formulas correctly. So here's what we have, right? So we're gonna say the formula with initial is this one. Oh, is this one? Is that one? It's this one, is that one. Formula with change in Y is this one, is this one. This is out, is this one. Formula with change in T is this one, is that one. This one is out. Guys, this is so much fun, man. I like doing this shame. And then acceleration, this one, this doesn't have. Here's a fun fact. This formula, you're gonna hardly use it. Yeah, askis. But then it's fine. If you wanna use it, by the way, you can give it a shot. So you're gonna use change in Y is equals to VI change in T plus half A change in T squared. Now our change in Y, we know it's negative 80. The initial velocity, we know that it is 4,9. The time is what we are looking for. And then acceleration, we know is negative 9,8. The time is what we are looking for. So now to get that time, guys, we'll say negative 4,9 change in T squared plus 4,9 change in T plus 80. Then you use the quadratic formula there. So the answer for change in T will be 4,57 seconds. And then done. You get your nice 4 marks there. Guys, if you're able to follow along with these two questions, you should be okay with any question that is going to ask you about hot air balloons. Okay, that is just simply how we do it. Now I have one last question on these hot air balloons that I want us to look at. it is going to be indirectly a hot air balloon, but you know, you will see. Let me just show you right now. I hope that we understand how to work with hot air balloons, and so far I also hope that you know how to work with one object and dealing with the calculations involving that, right? Remember, we're trying to make sure that we, you know, take you through these things step by step. You know, projectile can be very messy, but once you are mastering it, your life will be very, very easy. You know that in paper one, I have my projectile motion there, I have that. So two main beasts that we have to deal with is two objects, when you have two objects, and then when you have graphs. That's it. But you know, we will work through them, don't worry. Okay.